Welcome to week 3 of ITIS 3P91. I hope you all doing great. Are there any questions? Anything? Okay. And then I'll try to locate the chat button. It looks like. So can somebody confirm that you can see my computer?
I can see it, but I also have a question.
Oh, sure.
I noticed on the syllabus that it says we have a brief proposal due tomorrow. I was wondering if you're going to talk about that today.
Thank you so much. That is my first item on the list. Okay. Thank you. Yes, I will talk about the group project. Any other questions? I'm just going to adjust my computer so that I can also see your chart, but I couldn't see anything except this little button here. Okay, I have to click that one. And then I'm going to locate the chart. All right. So any questions beside the group project? Okay, somebody raise hand. Go ahead.
Yeah,
Questions?
I have a question. Are we going to be back in person next week, or are we doing online, continuing?
Yeah, I just got email from department. Our class ITIS 3P91 is scheduled to return to the campus. We are in the phase 2. Phase 1, people will move to the campus on February 1st. We are in phase 2, this class. That is February the 7th. So that is Monday, but our class is Thursday. So it would be February the 10th. February the 10th, we will return to the computer lab to accommodate student different needs. If you do not want to go back in person, it is fine with me, but on condition that you will attend the live lecture through the Teams. So when we go back to the lab, what happened is I will do similar way as we are doing now. I will conduct Microsoft Teams meetings. So you can use your laptop or you can use computers in the lab, your choice. If you use computers in the lab, you have SPSS installed on the computer lab. Okay, but I will do the lecture through Microsoft Teams. So if you decide you do not want to go to in person for whatever reason, you can still attend class at home. Like right now, you are attending class. Okay, so that is my plan. But during the test will be, our test 1 is February the 17th. February the 17th is our test 1. I hope everyone will attend in-person class unless you have special situation. Let me know. I will consider it on case-by-case basis. Okay. So any questions about returning back to the campus? Okay, and even after we return to the campus, the lecture will be recorded and posted on Sakai. Last week, unfortunately, the second part of the lecture was not recorded. I pressed the wrong button. Instead of quick record lecture, I probably clicked the record transcription. I don't know, but I didn't find the second part of our lecture recording, okay? All right, so that is when we are going to return to campus. Now return back to one student's questions about group project. there are several phases. Phase 1, you are going to select your team. It is 2 or 3 people. And if you have 4 students, that's fine with me, okay? But do not exceed 4. Do not have 5 students. Maximum 4 is fine. And today is the 27th, so tomorrow, what will be due? This 1-page proposal reduced to 1 paragraph. 1 paragraph is okay, okay? So just telling me your group members and your topic, okay? Is your topic about employment rate, or your topic is about inflation, or your topic is about Apple's computer sales, okay? Or your topic is about student enrollment. Just tell me your team members, your topics, and what are you planning to do with the topic? Are you going to do the after today, you may have some topic, because today we will do hypothesis test, okay? Are you going to explore relationship between variables, or are you going to compare population means, okay? So just brief, not 1 page. Please consider this 1 page to 1 paragraph, 1 paragraph, okay? And then the second one, detailed proposal. That is the 1 page. I didn't have that is the 1 page by March 4th. Okay, so in that 1 page detailed proposal, you have to tell me what is your project objectives, what is the problem, what is the methodology you are going to use. Okay, so including what is the background of your data. So that is a 1 page. Due March 4th. And the final, we have 15 minutes presentation. The presentation will be held in class Thursday, March 31st. We will see if for whatever reason you do not want to go to in-person class, this presentation we can make virtual presentation. We will see, okay, if majority students want to go virtual like this, we can go virtual, okay? So the final project due April 1st. So that is the outline for project. Any questions? Any questions? Okay, now, does anyone who haven't has a group? I assume you all has a group. Okay, I got questions. What exactly are we doing for 1 page proposal? For 1 page there are 2 proposals. The first one tomorrow, due tomorrow, that is 1 paragraph, not 1 page. In that 1 paragraph, just telling me your group members, what is your topics? What are you going to do with your topic? For example, if you are interested in the employment rate, so this is your topic, employment rate. What are you going to do with the employment rate? Are you going to compare man and woman to see if the employment rate are similar or not? Or are you going to compare employment rate with the income level? So give me a little bit detail, just a little bit. Expand it a little bit on your topic. That is 1 paragraph proposal tomorrow. Now on March 4th, it is 1 page proposal. In that 1 page proposal, you have to include what is the problem, what is the objective of your project, what is the methodology of your projects. So just what is actually the background of the context. Is your project about sales, or your project is about Apple computer distribution or market share? Okay, so that is the context. And then tell me the objective. What are you going to achieve by doing this project? What is the objective? And then methodology. What tools are you going to use to solve the problem? Okay, so I hope that answered the questions. Where we collect data, should this be included as part of our topic section? For the topic, for now, you can ignore the data collection. The one paragraph due tomorrow, just focus on the topic. If you can mention the data collection, that would be the great. Okay. Actually, data collection should be included in one-page paragraph, one-page proposal on March 4th. Any other questions? All right, so I love your questions. If you have any questions, feel free to type in the chat area. Try to make this window chat area visible, or unmute yourself, directly speak up. Okay, so what is the question? What if we don't find the data after we submitted the topic? After you submit the topic, you don't find your data, you can change your topic. That is one of the reasons I need a second proposal, March 4th. On March 4th, you have second chance to submit your proposal. Okay? Any other questions? You can change your topic. All right, so now we are going to go back to the agenda for today. So I'm just going to. Okay, now I can see both the chart. Okay. So last class, we did Unit 1 and Unit 4. Unit 1 and Unit 4 is about data variables, SPSS overview. Okay, so today we are going to go over 3 units, Unit 5 and Unit 7. So this is week 3. Unit 5 is about descriptive statistics. Unit 6, we are going to do t-test for both dependent samples and independent samples. Unit 7 will do univariate, multivariate analysis of variance. Okay, so that is, we may not finish Unit 7. If we don't finish Unit 7, so next class we'll continue with Unit 7. Okay, so that is the plan. Any questions? Okay, what I'm going to do, for some unit, in each unit, we have many lessons. For example, Unit 5, this is Unit 5. Unit 5, we have lesson 19, lesson 20, lesson 21, etc. Okay, for each lesson, I will follow the textbook examples. I encourage you to follow my steps if you can. If not, you can just watch my lecture and mentally participate. Okay. So now I will go over chapter lesson 19. Lesson 19. In lesson 19, we are going to open a data file. The data file is, I'm going to open my, so this is my SPSS. I'm going to open data file. That is for lesson 19. Lesson 19. Quick open. I may already did something. So your data file may look different from mine. Okay, so no worries. So the important thing is whenever you open the file, you save it in different name. In case something happened, you can go back to original data. So I'm going to file save as. And I have a folder, it is exercise or example. The file name, I would suggest original file name, followed by your initial. Okay. I probably already have that file name. Maybe I will add the date, January 27. Okay, so this is the data. What this data is about, if you go to variable view, you can see all the variables. Okay, all the variables. This skip, it is diet, hunger 1 to hunger 4. Skip is the estimate number of days students skipped lunch. That is the meaning of the skip. Okay, number of days skipped lunch. Diet measures the estimated proportion of days on diet during sophomore year. And the specific description of the variable, maybe I will refer to the textbook. So it is 19. Here, that is the variable definition. Oops. Okay, so what is that? What is hunger 1 to hunger 4? It is ratings of hunger on 4 consecutive days during the first month of sophomore year. 0 represent no hunger during entire day, 100 voracious during the entire day. Okay, and then we have variable PBI01 to PBI02. Those are positive body image. In a scale of 1 to 5, with 1 represent totally disagree, 5 totally agree. Okay, so positive body image. And then we have ATE01 to ATE05. Okay, and this is a positive attitude toward eating. Okay. Participants indicate how they feel about eating on a 3-point scale. -1 represent negative feeling, 0 represent neutral feeling, 1 positive feeling. And then OG01 to OG08, it is overeating guilt. On a scale of 1 to 5, with 1 totally disagree, 5 totally agree. Okay, those are the statements. Okay, there are 8 statements. For each statement, you rate 1 to 5, similar to other variables. Okay. All right. So any questions about the variables involved? Any questions about the variables? Okay. So those are the variable view. Okay, variable view. Go back to the data. Okay. So once you have this data, you want to create a variable, total variable. Total for what? Total for the 8. We have okay. So we have see this variable 801, 82, 83, 84. Okay. So remember what is the 8 represent? It is a positive attitude toward eating. Okay. Positive attitude toward eating. So because we want to do calculation about this ATE, I want to refer to here. So what is ATE 01 to ATE 05? It is a 5I positive attitude toward eating. Okay. For example, eating desserts. Okay. You can put number 1 for this one. The first item, eating desserts, means you have negative feeling about eating desserts. If you put 0 for this item, you have neutral feeling. If you put 1 on eating desserts, you have a positive feeling, etc. Okay, so that is the ATE variable. So what we are going to do, we are going to add all these 5 items together and give it a new name, ATE. So we want to add ATE1 to ATE5. Here, from 1 to 5, and we are going to add all these 5 items together. The result will put into a new variable called ATE. Okay. So any questions on what we are supposed to do now? Any questions? All right. So to compute a new variable, you go to transform, compute variable. And the variable name we call ATE. And it is just 5 items added together. Okay. You can quick use sum function, then opening bracket. After that, you quick ATE1, comma, ATE2, etc. 3, 4, and 5. So you want to add all these 5 items together, put the result as ATE. Okay, and then you click OK button. And you should have the ATE variable if you go. See, you created this variable. You just created this variable, okay? This is one way to do it. The other way, you can use, the other way you can do this, so compute variable. The same, I can delete, you can say ATE01 to ATE05, the same thing, okay? And then click OK button. Change existing variable, okay? So you get the same result. Okay. All right, so that is create a total variables. Okay. Sometimes we need to reverse the variables. For example, if original rating is 1 to 5, we want to reverse to 5 to 1. Okay, to do that, you can go to transform, record into same variables. You want to reverse, okay? Record into the same variables. And then what variables you want to reverse? For example, you want to reverse positive body image variable. So this is positive body image variable 1, and you want to reverse positive body image 0.3, and then positive body image 0.5. Okay, and then you click Alt and new values. So Alt value is 1, the new value is 5. Click Add. If Alt value is 2, the new value would be 4. Click Add. If Alt value is 3, the new value is 3. This step can be skipped because they are both 3. I will just add here. Alt value is 4, new value is 2. Alt value is 5, new value is 1. Okay, and then you click Continue, and then click OK button. So the ratings for a positive body image 0, 1, 0, 3, 0, 5 has been reversed. Okay. Any questions? So next we are going to compute another, we did total score variables. Sometimes we need standardized z-score. Remember what is the z-score? Okay, just try to pull out my notes. Remember, how do you calculate z-score? So z equal to original data minus mean divided by standard deviation. This is for sample. If it is for population, z-score equal to x minus mu divided by population standard deviation. This is for population. Okay, and how do you let Excel to do the calculation for z-score for all data? Okay, you do this. Moses said normal distribution. Yes, we use normal distribution to calculate the z-score. Okay. All right, so go back to my data here. This is my data. So you do this to create z-score. You do analyze descriptive statistics, and then click descriptive. Okay. So now, if you want to create z-score for the skip and diet, you want to create z-score for skip and diet, and then you move those variables into variables box, and then just click this button here. See, save standardized values as variable. Just click this button, you will get z-score. Okay, click OK button. Okay, and if you go back to the, this is the output, some basic descriptive statistics, okay, for these two variables. But if you go to original data, see, those two are z-score for skip, z-score for diet, automatically calculated. Okay. So any questions? So that is the creating the z-score. Okay. So basically that is the lesson 19, okay, lesson 19, to do some descriptive statistic, do the calculations for z-score, do calculations for totals. Okay. All right. Any questions for lesson 19? So next we'll go lesson 20. Okay, lesson 20. So I'm going to open lesson 20 data. Open. So for this data, we have three variables. Try to adjust my window so that I can see your questions. Gender, we use 1 represent man, 2 represent woman. That is the gender. Okay. Where the meaning of the variables appear on the test, like age. Yes, the variable meaning will be explained. Okay. Bad network connections. Okay. Any other questions? Okay, so this gender I explained, but sometimes I do not explain during the test because you can find explanation by quick variable view. If you click variable view, the gender is explained here for the label. The gender is explained here. So it is a gender of participant. Okay. And how do you know 1 represent what? 2 represent what? You click the values. When you click the values, you know 1 represent man, 2 represent woman. Okay. So if this is the test, I will not explain gender because you're supposed to find out by click the variable view, you will find the meaning. Okay. Okay, go back to the data. So we explained the gender. Next is the ethnic. So ethnic, value 1 to 5. How do I know 1 represent what, 2 represent what? You go to variable view. You have ethnic. It is ethnic status. And then you check the value. Okay, 1 represent blank, 2 represent Hispanic, 3 Asian, etc. 4 white, 5 other. So those are the ethnic. Okay, you're supposed to know, to find out. It is in variable view. Okay. And the last variable is job. Job has value 1 to 10. 1 to 10. So this is actually job classification. If you go to variable view, it is job category. Okay. 1 represent clerical work, 2 management work, 3 maintenance work, etc. So last one, 10, represent unemployed. Okay. So hope we understand the given data here. So once you are given this data, what are the questions here? Okay, so we ask 3 questions. You can ask many questions here. I will just ask 3 questions as example. Okay, for example, question 1, what are the frequencies or percentage of men and women in the sample? That is my first question. what are the percentage of men and women in the sample? Okay. And question 2, I will ask, what are the frequencies of percentages associated with ethnic status categories? Okay. So those questions can be found in the textbook. Okay. It is on lesson 29. Just quick, maybe. Not 29, 20. So those are the 3 questions we asked. Okay. 3 questions we asked. The 3rd question, what are the frequency or percentage associated with 10 job categories? Okay. So to answer those questions, we can use descriptive statistics. So go back here, go to Analyze, Descriptive Statistics, then Frequencies, and then move all these 3 variables to the variable box. So after that, quick statistics. And we want to know if you want to know the quantile, you can check out this. Okay, for example, how much percentage lower than, what is Q1, Q2, Q3? Okay, 25th percentile, 50 percentile, or 75 percentile. Okay. So here, you can pick the statistic you want. Okay. So I will just maybe do not pick anyone. I will just go to display frequency table here. And then I'll click OK button. So you can, from this output, you can see how much percent are men, 48% are men, 51% are women. Okay, and how much percent are blank? 16.6% are blank. Okay. 20% Hispanic, 14% Asian, 42% white, 6.7% others. And similarly, you can get the percentage for job category. Okay. So that is using SPSS to do qualitative analysis. Those are the frequency count, qualitative data. Any questions? Any questions so far? Okay, now you can create a chart. You can create a chart. For example, you can create a bar chart for the job. Okay. So to do that, you can go to Analyze, Descriptive Statistics, then Frequencies. Quick Reset button. You want to create a bar chart for job. So select job. And then under the charts, click the charts. Select bar. Select bar chart. Do you want frequency or do you want percentage? You have choice here. frequency or percentage. Okay. Maybe you just accept default setting frequency, then click continue and click OK. You have job category, this bar chart. Okay. So any questions? That is lesson 20, descriptive statistic for qualitative variables. Okay, qualitative variables. And the next, move on, lesson 21. Lesson 21, we are going to do the quantitative variables. Quantitative variables. So the data file we'll open is 21, lesson 21. File open, lesson 21, data file. Click open. All right, so this is the data file. So get the meaning of those variables. So it is lesson 21. So in this data set, we have 3 variables. Okay. One variable is HS GPA. It is a high school GPA score. HS high school GPA. And then we have a college GPA, COLL GPA. And we have gender with 1 is man, 2 woman. Okay, so these are the variables for here. High school GPA, college GPA, gender. Okay. So now, what are you going to do with this data? So we can do a lot of things. For example, we can compute overall descriptive statistics by go to analyze, then descriptive statistics, and then we can click explore. Now we want to move high school GPA to dependent variable, high school GPA and college GPA. And then we can select factor. Select factor. The gender is a factor. And when you click OK button, you have a descriptive statistics for men and for women. The mean, standard deviation, variance, minimum, maximum, range, etc. Okay. All right. So any questions? So I found a question. How do you get to explore page? Thank you. For how do I get explore page? You go to analyze descriptive statistics and then explore. Okay, explore. Okay. Other questions? Next, we are going to convert scores to z-score, not assuming normality. Okay, so what we are going to do next? we are going to do this. Out here. Converting scores to z-score and percentile ranks, not assuming normality. If you don't assume original data is normally distribution, what do you do? If you want to create the rank, okay, you do this. So you go to transform. Transform, then rank cases. Rank cases. We want to use college GPA. So select college GPA into the variables. And then quick rank types. Rank types. And make sure this rank is selected. This rank is selected. And then continue. Okay. After that, quick tires. Rank assigned to tires. Quick high. Okay, we want. So this is this selection. And continue. After that, click OK button. Okay. Looks like nothing happened, but now you keep. That is just a preparation work. Now you go. This is actually here. This is the rank. It's R, capital R represent rank. Okay. I didn't save this file in different name, so later I'm going to delete this variable I created. This is the rank, okay, based on college GPA. Based on college GPA.
Professor.
Yes, questions?
Why did we the low GPA higher?
I'm sorry, can you repeat your question?
I'm just wondering why we ranked the lower GPA as higher rank.
Let me see, college. No, we ranked lower GPA as lower, higher GPA as higher. So if you see, for example, this person college GPA 2.64, the rank is 58, okay? And the fourth person GPA 1.65, the rank is 6. That's why we choose higher. You can choose, remember when we select tires, you can choose low, you can choose mean, you can choose higher. So we want the lower the GPA, the lower the rank. If you want the lower the GPA, the higher the rank, you should choose low. Okay. So if you compare, this is original GPA, this is the rank. This is the rank. If you want to create the percentage, you can continue go to the transform, compute variables. Okay, and then if you want to create a percentage rank, you can type in PER, RINK. That is just the variable name. Okay, so you use the rank we just created. This is R rank, and this number divided by total number of people. Oops. So total number in the data we have, just try to add bracket, no here. Bracket, okay. So you use this one divided by 90, because we have total 90 students here. 90 students, and then times 100. You get the percentile. If you click OK button, and then go back to original data, you see you have the percentile value. Okay. So this percentile value means 6.60% mark are lower than these students, 1.75 students. All right, so that is the calculation. When you do not assume normality, you have to do this way, using rank cases. But sometimes we do assume it is normally distributed. Okay, when it is normally distributed, you can use this procedure, analyze descriptive statistics, and then descriptive. Now select, this is not the same data, so I pick the wrong data. So I'm going to close this data without, this is a lesson 20. Not saving it. So we are talking about lesson 21. Here, this is the data. Okay, so I repeat myself. Analyze descriptive statistics, then descriptive. Okay, now I will select college GPA, then quick save standardized values as a variable, and then click OK button. So first, I need to create a standardized value for college GPA. It is here, standardized value. After that, I go to transform, compute variable. So now I will create variable, name is GPA rank. So what I'm doing now is create a rank for GPA, assume the data is normally distributed. Okay, so GPA rank is the variable name. Okay, so after that, I'll have to type in reset. Because you assume it is normal distributed, so you are going to use CDF. Okay, CDF, that is represent for something related to the normal distribution. Okay, so dot normal. NORMAL, normal. Okay, opening bracket, and then you have to convert the z-score into the rank. Okay, so you move the variable. Let me see. This is the z. Remember, we created z variable. And then, because we are using standard normal distribution, the mean is 0. Standard deviation is 1. Okay. And after that, we multiply 100. Okay. And that's it. Click OK button. and go back to the original data, you have the rank. See, you have GPA rank. I just calculated. And this rank is assume normal distribution. Assume normal distribution. And this rank is not assume normal distribution. Percentage rank. This one is assume normal distribution. As you can see, there is not big difference. For example, a person ranked 57. If it is normal distribution, this person will be ranked 60. Okay, not that big difference. So any questions? We'll take break after I create a graph. Okay. So let's create a histogram based on college GPA data. So to create histogram, you go to graph, legacy dialogues, and then you have a histogram. We want to create histogram for college GPA. So select college GPA. And then display normal curve. Check out display normal curve, and then click OK button. So this is the histogram with the normal curve. Okay. So any questions? All right. So that concludes Unit 5, creating variables and computing descriptive statistics. There are 3 lessons. Lesson 19, Lesson 20, and Lesson 21. Let's take a break. After break, I will do Unit 6, student t-test. Okay. All right. So shall we come back at 10 after 2? Come back at 10 after 2. I'm going to stop recording. When we come back, please remind me to press record button. So for now, stop recording. If I stop recording and transcript.